Welcome to my new calculus channel. My name is John Gabriel, and today I'm going to talk to you about a special kind of ratio, the ratio of time, and how we got time and what it means. So let's begin. Now, you may have learned a little about the history of time and how it came about. Of course, excuse me, you need two things for time to be reified. You need the physical universe, and you need motion. So in a void universe, time is meaningless. There is no such thing as time unless we have objects and unless those objects are moving, so that we can talk about the change in position of those objects. And so time is a special kind of ratio. And the first water clocks were invented by the ancient Greeks, and the name of Ctesibios comes to mind, who lived in Alexandria or Egypt, I think, somewhere in Egypt, and he built the first mechanical water clock. But in any case, what is a rate? And I'm going to be discussing time as a rate, because a rate is really just a ratio between two related quantities. In fact, it's just a rational number. So some examples, as you see here, are 1, 2, half, and 5/8. And of course, a number is the most primitive rate. That is, it is a rate between two magnitudes, of which the one is a standard measure and the other the enumerator. So for example, the ratio 5:8 becomes a number in one of the following ways, which are both equivalent. We define the chosen unit into 8 equal parts. We divide the chosen unit into 8 equal parts and measure off 5 of those parts, as you see here. So the red is 1 part, black is another part, 8 parts, and we measure off 5. Or we can take the chosen unit and align 8 such units in a straight line, and then count off 5 of these units. And this is always the best way, because in geometry it's required to divide a given line segment into equal parts. But in algebra, this is not always possible. So for example, if we said 5 divided by 8 in algebra, it just simply becomes 5/8, because the 5 goes to the top of the vinculum and the 8 to the bottom. So I'm struggling to breathe right now, excuse me. So that's how we get ratio. Now, the ratio distance to time is a special rate because it tells one how fast or slow a given object might be moving. And of course, time is itself a ratio of distances. Now, in this diagram here, you'll see that the way we get time is by considering the distance between two locations. So if we look over here, and let's just see here for a second. Let me try and draw on the screen sketch. Okay, so if we look over here on the diagram, this distance here covered by this slight rotation is 460 meters, right? Which we call the second. And literally 460 meters to 1 meter is what we refer to as 1 second. Okay. Hope I'm not getting a heart attack. All right. So, what does 500 miles per hour mean? It means 500 miles to 1,000 miles because the Earth covers a distance of 1,000 miles from one point to another point at the equator. So it can mean 30 minutes or half an hour. It can also mean 828,000 meters to 1,000 miles. So, or many other different ratios. So the ratio 460 meters to 1 meter is called an Earth second, and we can hide it. And we do hide it when we write 1 second. So if we are talking about 100 meters per second, an object, any object traveling at that speed, we actually mean approximately 0.21739 Earth seconds. Okay, so 460 meters is what we call an Earth second. And we didn't have to define time in terms of minutes, seconds, and hours. We could have divided the day into any number of hours we liked and into any number of seconds. The chosen amount of hours, 24 hours, is probably due to the fact that 24 divides 360. And it would have been easier to work with a multiple of 360. And so it's also divisible by 12. So 12 and 24 both divide 360, which is also used to perform circular measure. And of course, any circle doesn't necessarily have to have 360 degrees. It can have any number of degrees you like, but the fixed circular measure is radian measure. So every circle, regardless, has 2 pi radians, and that does not change. You cannot change that. It's set. So what do we need for time? We need standard repeatable motion, okay? And to have standard repeatable motion, we need objects. And as far as we're concerned, objects are physical matter. Therefore, you need the universe. And if everything in the universe had to come to a standstill, even at the subatomic level, time would automatically cease to exist, okay? Time would become meaningless. So there's no such thing as the arrow of time or any of that other nonsense that you hear in mainstream academia. And of course, space-time itself is a load of nonsense, okay? Relativity theory is also nonsense. And in fact, the discrepancies in GPS units, etc., are attributable to these facts, not to Einstein's gibberish. So the two theatrical physicists, I call them theatrical because they were not theoretical, Einstein and that crippled moron, Stephen Hawking, created a lot of theory that is just basically crap, excuse my language. And you can read also my world famous article on what is time on LinkedIn to understand a lot more about what is time exactly, but it's just a ratio. And in what I've tried to do in this video, and I'm really struggling to breathe right now, is explain to you what is time. So if I'm able to, I'll try to explain these things again in a future video. I'm John Gabriel. This is a new calculus channel. Till next time, goodbye.